everybody. So in today's video, I'm going to be clustering these stocks pictured here as volatilities so I can see which stocks volatilities are behaving the same. So let me go ahead and start by loading my library. So I'm going to import NumPy as NP, import pandas as PD, import matplotlib.pyplot as PLT, and look at my notes here. I need to import some scikit-learn libraries. So it's going to be from sklearn.decomposition, import PCA for principal component analysis, which we're going to be using later in this video. From sklearn.preprocessing, import standard scalar, which I'm going to be using to standardize the volatility data. And from sklearn.cluster, import k-means, which is going to do the clustering. So before I get to the principal component analysis and stuff, I need to load the data. So I'm going to define a function, and I'm going to call it stock data. And it's not going to take any arguments, as the stock list is right up here. What I'm going to do is create a variable called close equals empty list. I'm going to create a variable called t0, which equals 2024 01 01. This is how far I want to look back in the data. And then I'm going to do for stock in stocks, it's going to be data frame equals pd.readcsv, f string of stock.csv, and then it's going to be df equals df date greater than or equal to t0, and then it's going to be close.append df of adjusted close dot values dot to list, and then here it's going to return numpy array of close. So I'm going to come here and just call this c equals stock data. Okay, so I have the close prices. I need to compute the returns. So it's going to be r equals c of 1 divided by c negative 1 minus 1.0. And let me go ahead and print the return. So print r, so python 3 vc.py. Okay, so there's an issue. Let me see if I can fix this. So close equals empty list df adjusted close. Okay, let me go ahead and open one of these. So it's okay. So there shouldn't be an issue with this. Let me go ahead and print df and then break. I want to see like what this looks like. So reset. Okay, so it goes to 2024. I don't quite see what the issue is. Oh, the transpose might have done it. So reset. Protected shape. Okay, so let me do print c.shape. Let's just understand if the dimensions are not right. Okay, I think I know what the issue is. So instead of filtering it out by date, I'll just call this t0 equals 200. So this will be negative T0 to current. So now let me run it. Okay, so yeah, we have 200 days, 27 stocks. So yeah, there must have been a mismatch in one of them. Okay, so then I could just do R equals C 1 divided by C negative 1 minus 1.0, and then print R. So this should do it. Okay, so we got all of the returns. So now to get the rolling volatility. So I will come over here. Actually, I think there's a simpler way to do this. I think it's just, I'll call this df equals pd.dataframe of R, and then the columns equals, actually I don't even think I need to specify the columns, just pd.dataframe of R, print data frame. Okay, so now I can do percent change. Or no, it already is in percent change. STD. No, that's not. Okay, no, that's not what. No, it's not creating a rolling window. So yeah, I scratch that. I don't quite know how to use that technique, so I'm going to use my technique. So I'm going to call this def rolling vol, and it just takes the argument of R, and then I'm going to define a window equal to 30 days, and then I'm going to do for I in range window to the length of R. So this is going to be, I'm going to call this x equals R I minus window to I, and then I'm going to do mn equals x dot shape, and then it's going to be mu equals 1 divided by m times numpy dot 1s of m dot x, and then covariance is going to be 1 divided by m minus 1 times x minus mu dot transpose dot x minus mu, and then the standard deviation is going to be numpy dot square root numpy dot diagonal of covariance matrix dot to list, and then I'm going to do result equals empty list, and then I'm going to do result dot append standard deviation return result, or rather return numpy array of result. So now I will come here and do RV equals rolling vol of R, and print RV dot shape, and then print RV. So let me go ahead and hit reset on that. Run it. I don't need that to be visible anymore. Okay, so 169. Yeah, it took the right amount. So we have all the rolling volatilities now. So I can get rid of that. So now let me boot my notes back up, because I'm going to put it through the libraries now. Where'd it go? Okay, so the first thing I need to do is define the standard scalar. So that's going to be scalar equals standard scalar, and it's going to be vol equals scalar dot fit transform of RV dot transpose, so that way it could individually look at each group. And then it's going to be, I'm going to set clusters equal to 3, no, I'm going to do it to like 5. And then I'm going to do k-means equals k-means, n clusters equals clusters, random state equals 0, and n init equals auto. And then I'm going to transform the data into cluster labels equals k-means dot fit predict vol, because that's the normalized vol. And then, according to my notes, it's going to be PCA equals PCA n components equals 2, because we're just going to have a 2D graph, and it's going to be PCA dot fit transform of vol again. Oh, no, it's going to be, yeah, it's going to be vol. So now that I have that, I need to return the PCA value, so I'll just call this VPCA equals PCA. And now I'm going to declare a figure equals plt.figure, ax equals fig.add subplot 111, and then it's going to be for XXYY in VPCA. Maybe I'll close these into a tuple. Let me go ahead and print this out. So print XXYY. I want to see what I'm dealing with. Okay, good. So what I can do now is just do ax.scatter XXYY. Wait, let me go ahead and print out cluster labels as well. Print cluster labels. Okay. 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, 27 stocks. So it's going to be... Oh, no, I don't need my notes anymore. It's just the plotting part now. So I'll go back to do for XXYY in VPCA. I will do... Well, actually, okay, before I do that, let me go ahead and print list set of, what is it, cluster labels. Okay, so there's 5 groups. So I'm going to assign a color up here. So I'm going to define colors. Takes an argument of X. So let me do this as return. Actually, let me just do like a gangster Python function. I'll call this colors equals lambda of C, and it's going to be red if C equals 0, else orange if C equals 1, else red, orange, yellow. No, I don't want to do yellow. I'll do green if C equals 2, else blue if C equals 3, else purple. Yeah, so I'll do it like that. So let me get rid of this and do plt color equals list map colors to cluster labels and print plt colors. So let's see how this runs. Okay, good. So now I will do so I need stock, I need color, I need XX and YY in zip. So this is going to be stocks, PLT colors. I believe I'll have to wrap this inside a tuple. So this will be VPCA. And then let me go ahead and just print these out. So print stock color XX YY. So reset, run it. Okay, so now we can get to the plotting. So this will be AX dot scatter xxyy color equals color. I'll call it x color. So x color equals x color. I'll leave it like that, but I'll do ax.annotate. So this is going to be stock xy equals xxyy, and then plt.show. Let me set the title too, so ax.setTitle, group stocks grouped by volatility behavior, ax.setXtitle, no, xlabel, principal component 1, ax.setYlabel, principal component 2, and then now that I have everything, run it. Okay, so wow, we have the graph. So these are all of the stocks grouped by their volatility. You know what? I think what I'm gonna do is also generate ellipses around this because I want this to be like a good visual tool. Um, so I'm gonna exit that. Now, what I'm gonna do is I'm gonna come here and I'll declare a variable called data equals empty list, or rather, it's gonna be red, orange, yellow. No, not yellow. Green instead of yellow. Let me come back up to the colors. Red, orange, green, blue, purple. So red, orange, green, blue, purple. Okay. So this is going to be okay, so it's going to take I'm trying to think it's been a little while since I've done ellipse math. I want it to have the center point. Yeah. So what I'm going to be doing here is data of x color dot append xxyy. Okay. So now that I have that, I'm going to come up here and define ellipse. Ellipses, so it's going to take data as an argument. To simplify it, I'll add color as an argument too. So it's going to be xy equals data color. Or rather, I'll just call this u equals data color. But I have to make sure that they're wrapped in NumPy arrays. Yeah, so it's going to be NumPy.array of data color is going to be xy equals u 0, u 1. So then it's going to be a equals numpy.a range 0 to 2 times numpy.py plus numpy.py divided by 16, numpy.py divided by 16, and then I will do mu of x, mu of y, or rather no, no, yeah, it would be. So it'll be mu x equals numpy.mean of x, mu y equals numpy.mean of y, and standard deviation x, numpy.std x, standard deviation y, numpy.std y. So then it'll be ux, no, I'll call it ex and ey. Ex, ey equals empty list for t in A. It's going to be ui is going to be numpy.cosine of t. Uj is going to be numpy.sine of t. So I believe this will be mu of x plus sdx times cosine, mu of y plus sdy times sine, and then this will be ex dot append ui, ey dot append uj, and this is going to return ex, ey. So I'll come down here and go to for X color in PLT colors. It'll be EX, EY equals ellipses of data and X color. And then it's going to be AX dot plot EX, EY color equals X color. So now run it again. Okay, and here we have it. So we have the ellipses. So we could see that SPY, Raytheon, Microsoft, Northrop Grumman, Lockheed Martin, their volatility is behaving very similarly to each other. Let me make this a bigger graph. We have JP Morgan, Wells Fargo, Goldman Sachs, Ford, Netflix, Google. Their volatility is behaving similarly. Oracle's a little bit of an outlier here. Nvidia, Palantir, and Tesla are not grouped with any of the stocks, so they're kind of like in their own grouped volatility. But yeah, I think yeah, I just wanted to plot these out. So yeah, I think we just about covered everything we needed to in this video. So I thank you all for watching this video. I'm gonna keep coming out with more and more good content. So stay tuned. Peace out.